Today we're going to look at some sine and cosine curves, and it's our job to figure out what the equation of these curves are. We've done the reverse of this in the last couple of days. We've been given an equation and we've been asked to graph or sketch the graph of it. But now what we have is, you can see this is on page 9. We've skipped over page 8 of our notes. So this is page 9 of our notes, 11-4. And you can see that we're given 4 sine or cosine curves on the front and a couple on the back. And now it's our job to come up with equations of each one of these graphs. Now remember, there are an infinite number of equations that you can write for each graph, but I'm going to tell you how to do the most common ones. So what we have to calculate, or we have to figure out, are 5 different things when we look at a sine or a cosine curve. So if you take a look at this first example, number 1, usually we just take a look at it starting at the y-axis over to the right. Our first job is to figure out whether this is a sine or a cosine curve. And hopefully, from what you've seen so far, you remember that sine curves, if they haven't been shifted, they start at the origin. So because this curve starts at the origin, this is a sine curve, as opposed to number 2, which doesn't go through the origin. This would be a cosine curve over here. So that's step 1. Determine whether it's sine or cosine, and then you have to figure out whether it's upside down or not. A regular cosine curve starts at the origin and goes 0, max, 0, min, 0, if you remember from the other day. So this sine curve is right side up. Right? If it was upside down, it would start here and go 0, min, 0, max, 0. So this is a right side up sine curve. So that's step 1. Step 2, you have to figure out what the amplitude is. That's the A value. And all you have to do is find the maximum point on these curves, and that's the A value. Like in this example, A is equal to 3. On step number 3, we have to find the period, and this one is a little bit tricky at first until you get the hang of it. But the period of the graph, if you remember, it's how long it takes for one full cycle. In other words, what is the x distance from start to finish of one full cycle of the sine or cosine curve that we're looking at? Once you figure out what the period is, then you have to calculate the b value, because up here in the oh my gosh, are you not? Up here, you can see that we're going to write our equation in this form. It's either going to say y is equal to, this a gets filled in with a number, this b will get filled in with a number, and if there's a horizontal shift, oftentimes there's not, but if there's a horizontal shift, we're going to be putting a value in for c, and after we've figured out whether it's a sine or a cosine curve. So we've calculated the A value in step 2. We're calculating the B value in step 4. So this is the B value. This is really important. After we figure out the period, we calculate B. And then the last thing to do, if there is a phase shift, the C value, we have to calculate how far left or right it has been moved, and then plug that value in for C. And remember, all these C values are going to be in radians. The A and B values will just be regular numbers, not radians. So let's start with this first example. We have to write this equation as a sine curve, and then we'll follow that up by writing another equation of the same curve, and we'll call it a cosine curve. We'll do 2 for each. So we've already figured out that this is a sine curve that hasn't been shifted. So I think we'll write this over on the side here for the sine curve. That's step 1. Step 2, figure out the amplitude. The A value, the high point is 3, so A is equal to 3. Step 3 is the period. Well, you just go 0, max, 0, min, 0. And after that 5th important point, that distance from here to here is the period. So the period on this graph is equal to 2 pi because it hasn't been shrunk or stretched. It's just a regular 2 pi. And then step 4 says we have to figure out what b is. The b value is equal to 2 pi divided by the period, which is 2 pi. So 2 pi over 2 pi is equal to 1. And then step 5, the phase shift, has this been shifted left or right at all? Well, no, it hasn't been shifted because it's starting right there at the origin. So C is equal to 0. And so now we have all of our important numbers that we need to plug in to this shell up here. Y is equal to A, which is 3. This is a sine curve. B is 1. So we usually don't put a 1 in here. So if B is 1 and C is 0, all we have to do is put an X in here. And if you want to surround this with parentheses, that's fine, but you don't really have to. So there's y equals 3 sine of x, and if you want to check that on your calculator, you can just plug in y equals 3 sine of x, zoom trig, and see that this will match. Now what we're going to do is write an equation of a cosine curve for this very same thing. So let's say we're going to call this a cosine that's been shifted. So over here we'll say, well, what if we call this a cosine instead? Well, the A value doesn't change. A is always equal to 3 because that's the high point. So once you figure out A in one spot, it's always the same. And the same thing goes with the period. Once you figure out the period, on step 3 of your original one, the period stays the same, does not change. So that's 2 pi. And since the period is the same, the B value stays the same. So there's no calculation necessary. And then the C value is what's going to change, because C, being a cosine curve, well, cosine curves start at the top and go max, 0, min, 0, max. And if you wanted to start it here, you could, or if you wanted to start your cosine curve back here, you could do that also. 0, or max 0, min 0, max. So it really doesn't matter if you call this a right shift or a left shift. There are many answers to this. So let's call this, let's say what's happened to this. This has been shifted to the right. If we call this a cosine curve, it's been shifted to the right by, there's not a tick mark here, but this tick mark should say pi over 2. And there's a tick mark down here that should say 3 pi over 2. That's 90 degrees, 180 degrees, 270, and 360. So this has been shifted, this cosine curve has been shifted to the right by pi over 2, if we want to call this our cycle. So because it's to the right, C will be negative. Right shifts are negative. So C is equal to negative pi over 2. So let's plug all of this information into our equation. We can also call this y is equal to 3 is the amplitude, cosine, and the B value is still 1. And now the x value minus pi over 2, we'll say this has been shifted to the right by pi over 2. We can just check our answer in our calculator here, making sure we're in radians mode. Y is equal to 3 cosine x minus pi over 2. No zoom trig. So you can see that this matches perfectly. The other thing we could have done is we could have called this a left shift. A left shift by 3 pi over 2. This tick mark is 3 pi over 2 negative. So if we wanted to say plus 3 pi over 2 for the left shift, we would have also gotten the same thing. So I'll just show you that here's another answer to this question. Plus 3 pi over 2. And then when you graph that, you can see you get the exact same thing, which is really just a sine curve. All right, so there's 3 different answers to this question. Now we'll go through the same process a little more quickly in the next ones. Number 2, well, this is a cosine curve, basically, because it doesn't go through the origin. So step 1 says, let's call this cosine, but it's upside down, because usually cosine curves start at the top and go to 0 and then go down to the bottom. But this is upside down. So what this is going to affect is the A value. Because this is upside down, A is going to be negative. And the amplitude is 2, so we'll call A negative 2 because it's been upside down. Step 3 says, what is the period of this graph? Well, this graph goes min, 0, max, 0, min. And after the fifth important point, it looks like 2 pi is the period, which makes b equal 2 pi over 2 pi, which is 1, just like example 1. And then the c value, this has not been shifted left or right at all. I mean, if we want to treat this as our cycle here, so c is 0. So we can call this y is equal to negative 2 cosine of 1x. Or if you want to put parentheses around there, you can. So there's one of the answers. Now if we want to call this a sine curve, well, sine curves start at the 0, 0, max, 0, min, 0 if we continued this on up. So here's a sine curve. And this has been shifted to the right, because usually sine curves start at 0, but this sine curve has been shifted to the right by how far? This is pi over 2. So just like in this other example, we can call this y is equal to, everything else stays the same. It's not upside down though, this is a right side up sine curve, so we'll have that as a positive 2 sine, and then because this has been shifted to the right, we can call this x minus pi over 2, and there's our sine example. So if you wanted to just check this out, we can say 2 sine of x minus pi over 2, and we should get the picture that they show us. Yeah. Yeah. And that's this exact same graph here. Number 3. Number 3, this is basically a cosine curve because it doesn't start at the origin. It starts way up here at the max, 0, min, 0, max. Here's my fifth point right here. You should mark all those important points, max, 0, min, 0, max. So step 1, this is a cosine curve because it's not starting at the origin. Step 2, what is the a value? Well, it looks like a is 4. Step 3, what is the period? How long did it take to get to that fifth important point? Well, this period is actually ending at pi because that's one full cycle here. So now step 4 says let's calculate b. b is equal to 2 pi divided by the period, which is pi. 2 pi over pi is equal to 2. So we'll plug in b equals 2, and step 5, c is 0 because this is not a shift right or left. So when we write this equation out, y is equal to 4 times the cosine. B is equal to 2, so we've got 2x. And if you want to put parentheses around that, you can. And if you put that in your calculator, you'll see this exact same graph coming up. Now let's call this a sine curve instead of a cosine curve. Let's see, this sine curve, if you wanted to start it on the x-axis like sine curves do, you would start it here. 0, max, 0, min, 0. So here's a sine curve. I'll write it in red so you can really see that it's a sine curve that's been shifted to the left. So step 1 says, let's call this a sine curve. The a is still 4. The period is still pi because it's just like before, which makes the b value equal to 2. And the only thing that changes is the c value on step 5. Well, this has been shifted to the left. And this is actually to the left of 1/4 pi because right here, this is negative pi over 2, halfway in between. And this is halfway in between 0 and negative pi over 2, which is pi over 4. And I'm putting that as a positive number because it's a left shift. So if we wanted to write this as a sine curve, y would be equal to 4 times the sine of 2 times x plus, because it's a left shift, pi over 4. Let's take a look at that. Y is equal to 4 times the sine of, now watch this parentheses, you have to go 2 and then open up your parentheses, and then it's x, this is a left shift, so it's plus pi divided by 4. Take a look at this, 2, the b goes on the outside, and then that x goes on the inside, and here is your left shift of pi over 4. So let's take a look at that. And you can see that's the exact same graph as what we have. And if you take a look way up here, you can see that that b values is on the outside of the parentheses, and then just the shift goes beside the x. So the b goes on the outside. That's why this b is going on the outside of the parentheses. All right, next one. This one's starting at the origin, so it looks like it's a sine curve. So step 1 says this is sine. Step 2 says what is the amplitude? Well, it only goes up to 1, so a is 1. 3 says what is the period of this graph? Well, what's happened here is we've got a 0, max, 0. We've only gone through a half of a cycle here, between here and here, because we really have to go on to get to the other half. So let's write this down. We've got a 1/2 of a cycle in 3 pi. That's where it ends. A half of a cycle ends in 3 pi. So that means a full cycle must be double that, must be in 6 pi. So that's the period of this graph, is 6 pi. Now we have to calculate b. b is equal to 2 pi divided by the period, which is 6 pi. And 2 pi over 6 pi is 1/3. So b is 1/3, and c is 0, because it hasn't been shifted from the origin. So let's write this down. Y is equal to 1 times the sine of bx, so it's 1/3 x, and no c value, so we can just put it in parentheses like that. And if you want to see this on your calculator, when you zoom trig, it'll only go out to 2 pi. That would be the x max. But if you wanted to go all the way out to 3 pi, you would just change, this is x max. So when we put this in to check our answer, this is the sine of 1/3 x. We don't need anything more. But our window, instead of going to, this is almost negative 2 pi, let's go out to 3 pi for our x max. That's under the window. So press your window button, change x max so it looks like that. And then when you press the graph button, you'll get the picture that you see on the paper. You'll see a half of a cycle completed, and this is 3 pi over here, this x max value. So there's that picture. Now if we wanted to figure out what the cosine curve is, well, I guess we'll start up here at the top for this cosine curve, and this goes down like this. It's not even a complete cosine curve, it's just a little bit of it. But all we really want is we want to figure out what this shift has been. Well, it looks like this has been shifted to the right. And then it's been shifted by exactly halfway between pi and 2 pi, or between 180 and 360, is 3 pi over 2. It's not written here, but you can figure that out, I hope. So this has been shifted to the right, this cosine curve, by 3 pi over 2, which is the c value. So let's do a cosine curve. This is y equals the cosine. Sorry, the bell rang in the middle of what I was writing down. So anyways, we figured out that it was a right shift of 3 pi over 2. So if you want to write the equation of that as a cosine curve, it's cosine in the calculator. The calculator automatically opens up this parentheses on you. Then you put in the 1/3, and then you have to open up another set of parentheses in order to get the right and left shift to be right. So it would be x, and a right shift means minus, so x minus 3 pi over 2. And hopefully when we get this into our graphing calculator, I already did it, cosine of 1/3 x minus 3 pi over 2. And this goes out to 3 pi. Let's see, our window, if we change our window, I changed mine in the middle of things, so out to 3 pi. Then when you press the graph button, it'll look exactly like the original one. So there's your cosine curve for that one. The next couple of examples are going to be, both of these are going to be shifted, cosine and shifted sine, because this one doesn't start at the origin, and it doesn't start at the highest or lowest point either. So each one of these sine and cosines is going to have a shift. So what I'm going to do is I'm going to take colored pencil, and I think I'll start with a sine curve. Now you can start the sine curve here if you want, because it starts at the 0 and goes 0 max, 0 min. Or you can start the sine curve way back here if you want. It doesn't really matter. I think I'll start mine right here. So here's 0, max, 0, and then you can't see the rest of it, but it doesn't really matter. What's happened here on the x-axis is this point right here is pi, and this is pi is 180, and this has been divided up with 4 tick marks. So each one of these tick marks is 1/4 pi. 1/4 pi, a half a pi, 3/4 pi, and 1 pi. So that's kind of important as far as the shifts go, how you're going to calculate that. So let's just put these in. This is 1/4 pi, which is pi over 4. This is 2/4 pi, which is pi over 2. This is 3/4 pi, which is 3 pi over 4, right? There's 180 degrees. This is 90 degrees. Here's 45 and 135. So 3 pi over 4 is where we're starting this. This has been a sine curve that's been shifted to the right by 3 pi over 4. The amplitude is 1. Now let's get the period. How long does it take to go through one full cycle? Well, what I've just drawn is a half of a cycle. You could do it this way if you wanted to. Figure out how much horizontal distance is in a half of a cycle and then double it. So we've got 1, 2, 3, 4. We've got 4 tick marks, and 4 tick marks represents pi. So from here, from this to this is just pi. That's the distance because it's 4 tick marks. And if that's a half of a cycle, one full cycle will be 2 pi. So we can start filling this, all of the pieces of information we need. So first one, we're going to write this as a sine curve. The second one is the amplitude. The amplitude is 1. The period is equal to 2 pi, which, 3, so which makes the b value 2 pi over 2 pi, which is 1. And then the shift has been to the right by 3 pi over 4. So that's going to be a minus when we put our formula down. So y is equal to 1 times the sine. Let's see, the b value is 1. So we've got open up x minus 3 pi over 4. That's the right shift. And the next thing we're going to do is write this as a cosine graph. So cosine graphs start at the top. So top, max, 0, min, 0, max. Here's your cosine curve right here. And how much has this been shifted? This has been shifted to the left by 1/4, 2/4, 3/4, or 3 pi over 4. Left, 3/4 pi. That's the cosine curve. And everything else is the same, the a and b values. So this is going to be the cosine of parentheses x, left means plus, and it's been shifted 3 pi over 4. 1, 2, 3. And we can check that in our graphing calculator if we want. The sine of x minus 3 pi over 4. I'm going to zoom trig because that's just a regular window. So that's the same graph as what we have. And then the other one was cosine of x plus 3 pi over 4 should give us the same graph. Yep, and it does. All right, and then the last one here, we'll start out with our sine curve. Our sine curve starts right here on the x-axis, so I'll just trace out 0, max, 0, min, and 0 would be over here. So this again, here's pi, and this is divided up 4 ways. So this first point would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And again, we've got a half of a cycle like we did last time. We've got a half of a cycle in 1, 2, 3, 4 pi over 4. So this from here to here is 1 pi. So if you go all the way over here, one full cycle when it starts at here and ends at here, this is 2 pi. This is one cycle. Looks like the amplitude is 2. I'm just going to go ahead and write the equation here. This is a sine curve. Y is equal to, the amplitude is 2 times the sine. Now the b value is 1 because the period is 2 pi. So I just have to open up parentheses. A right shift means minus, and then this is pi over 4. Now let's see about the cosine curve. I'll start the cosine curve up here. Max, 0, min, 0, max. There's your cosine curve. And this has been shifted to the left by 1, 2, 3, 4, 5 pi over 4. If each one of these is 1 pi over 4, we're just counting out the fifth one, 5 pi over 4. Or if you wanted to, you could call it a right shift of 3 pi over 4. It's the same thing. So our equation here would be 2 cosine parentheses x, a left shift means plus, plus 5 pi over 4. Or if you wanted to call this a right shift of 3 pi over 4, you can also write it as 2 cosine of x minus 3 pi over 4. That's one of a million different correct answers. All three of them will give you the same graph. Now the last thing I want to show you is a tangent curve. Tangents are really a lot different than sine and cosine. If you put y equals tangent of x in your calculator, and oops, I didn't clear out everything out, and I'll just do zoom trig. Here's your tangent curve. It's a repetitive cycle over and over and over again, but it looks different because what we have here is we have this is a full cycle. We have 3 full cycles of a tangent coming up, and we have a half a cycle here and a half a cycle here. So that's what this looks like. Now there are important points on the sine curve or tangent curve. It starts at 0, 0. And here again we've got pi out 1, 2, 3, 4 tick marks. So this first one is 1 pi over 4. And this is 2 pi over 4. Which is pi over 2. This one is 3 pi over 4. And then this is just plain old pi. On a tangent graph, what you're going to have to do is you're going to have to draw dotted lines where the break in these cycles, this is one cycle, and this is one cycle, and this is one cycle. And in between each one of these cycles is a dotted line vertical. So draw this in between every single cycle you see. And we'll talk about this a little bit more on the next video. But these dotted lines are called asymptotes. We've talked about them before. The asymptotes are between each cycle. Oops, CYCLE. Okay. And the asymptotes occur at 90 degrees here. This equation here is x is equal to, because it's vertical, and the x value is pi over 2. This one is x is equal to 3 pi over 2. And this dotted line is negative pi over 2. And this one right here is x is equal to negative 3 pi over 2. And the reason why they're asymptotes is because for the tangent, you can't do a tangent of pi over 2 or a tangent of 90 degrees. If you remember, that would be undefined. So x is equal to 1 pi over 2, 3 pi over 2, and you can keep on going up. If this would show up, 5 pi over 2, 7 pi over 2, and on and on and on we go, because the tangent is undefined there. And we talked about that in the last chapter, the undefined places where tangent goes. That'll be nice on my video, huh? All right, so just quickly to finish up this page 10, what is the domain of this? The domain means what are the x values? The x values here are all real numbers, just like sine and cosine, except the x values that are the asymptotes. So x is equal to plus or minus 1 pi over 2, 3 pi over 2, 5 pi over 2, and on and on and on we go because it's just undefined there. What is the range? Well, you know what? You should probably put arrows at the ends of these because they go down forever and up forever. The range is all real numbers. There is no amplitude because it goes up forever and down forever. It doesn't have a highest point, doesn't have a lowest point. There's no amplitude. And the period, the amount of or horizontal distance it takes to get through one cycle, it's not 2 pi like the sine and cosine, it's just 1 pi. That's how long it takes between each one of these dotted lines to complete one cycle. And the equation of the asymptotes, I think we already wrote them right here. I'll just put an arrow. Those are the equations of the asymptotes, or you can also call, these are the equations. They're actually all the plus and minus odd values of pi. These graphing calculators don't draw the asymptotes in, but there's a dotted line in between there. And that's it for today. Have a great weekend, and I'll see you on Monday.